Today, we are going on a journey from Earth to the center of our own galaxy, the Milky Way. This won't be a fast, thrilling ride, but a slow, gentle drift through space. A calm, science-filled exploration you can relax to, unwind with, and, if you'd like, fall asleep to. Together, we'll imagine what it would be like to leave our home world, travel at the speed of light, and cross the vast distances that separate us from the heart of our galaxy. Along the way, we'll pause in each region we pass through and quietly reflect on how far from Earth we've traveled and how many years would have slipped by back home. As you settle in, you might imagine yourself lying somewhere comfortable and dark, as if you were outside under a clear, quiet night sky. The Milky Way stretches from horizon to horizon, a soft, hazy band of countless stars. For most of human history, we could only look up at this band and wonder what it really was. Now we know it is the disk of our galaxy, viewed from the inside. We know that our sun is just one star among hundreds of billions. And we know that, far away toward the constellation Sagittarius, there lies a dense, hidden region where a supermassive black hole marks the galactic center. Tonight, our journey is a thought experiment, a scientifically grounded meditation. We will imagine traveling at the speed of light, even though no spacecraft with mass can truly do this. Think of it as a way to understand the scales involved. At the speed of light, a light year becomes not just a distance, but a measure of time. 1 light year corresponds to 1 year passing back on Earth. Each step we take will be measured both in how many light years we've traveled, and in how many years the people on Earth would have waited, watching the sky, as you moved farther and farther away. We begin gently, close to home, lifting away from Earth without any jolt or strain. The blue of the atmosphere fades into the deep indigo of near space, and then into the blackness beyond. City lights and weather patterns blur together, then dissolve into a tiny, glowing sphere as you pull away. The moon falls behind you, its grey surface illuminated by the same sun that is now shrinking into a bright, distant star. Planet by planet, the familiar members of our solar system slide past in silence. The rusty disk of Mars, the swirling bands of Jupiter, the icy elegance of the outer worlds. All the while, you continue outward, at light speed, but the experience feels unhurried and smooth. After about 16 hours of this steady motion, you reach an invisible boundary, the heliopause. Here, the solar wind, streams of charged particles flowing outward from the sun, meets the thin gas of interstellar space and is finally slowed and pushed back. Inside this bubble, the sun's magnetic field and outflow dominate. Outside, the environment is shaped by the broader galaxy. Crossing the heliopause, you are only about 0.0018 light years from Earth, much less than a single thousandth of a light year. To the galaxy, this distance is almost nothing at all. But symbolically, it is a powerful threshold. You have left the solar system and entered interstellar space. The region beyond is often called the local interstellar medium, and more specifically, our sun is moving through something known as the local interstellar cloud. Despite the poetic name, it is incredibly tenuous. If you could gather the gas here into a container, you'd find only a few atoms in each cubic centimeter, so empty that any vacuum we could create on Earth would still be denser. Yet this delicate, ghostly gas is shaped by supernova explosions, interstellar magnetic fields, and the slow orbits of stars around the galaxy. You drift through it peacefully, a tiny traveler in a space that is almost unimaginably vast and quiet. As time goes on, you keep moving outward at the same steady speed. The sun behind you fades into the general background of bright stars. Ahead and around you, the night sky is packed with points of light, yet the distances between them are so great that they might as well be islands in an ocean. After about 4 1/3 years of travel at light speed, you reach the distance to Alpha Centauri, our nearest stellar neighbor. 4.37 years have passed on Earth. If someone had watched you leave as a child, you would be older now by more than 4 years, and the world you left behind would have moved through several cycles of seasons, events, and quiet ordinary days. Here, in the local stellar neighborhood, you pass by the Alpha Centauri system, which is actually a trio of stars, two sun-like stars in a close dance, and a smaller, dimmer red dwarf called Proxima Centauri a little farther out. Around Proxima, astronomers have detected at least one planet, and perhaps more, orbiting in a gentle, distant trace. Nearby, other small, cool stars like Barnard's Star and Wolf 359 drift through the darkness, each with its own potential for planets, asteroids, and comets. This is our immediate galactic neighborhood, a scattering of stars separated by light years, all loosely bound to the same spiral arm pattern. From your vantage, the journey still feels serene and slow. You are moving impossibly fast by everyday standards, but the galaxy is so large that even light seems patient here. Ahead lies the broader structure we call the Orion Arm, or more precisely the Orion Spur, a sort of minor spiral feature in which our Sun just happens to sit. This spur branches between two of the galaxy's major spiral arms and contains bright star-forming regions, dark clouds of molecular gas, and countless stars of different ages. As you glide deeper into this region, thousands of years begin to pass on Earth. At 2,000 light-years from home, you have traveled across a meaningful chunk of our local spiral structure. 2,000 years of Earth history would have unfolded in your absence. Empires would have risen and fallen, languages transformed, coastlines reshaped. Yet out here, in the Orion Spur, the overall arrangement of stars would look almost unchanged. Galactic evolution is so slow that even thousands of years are just a faint heartbeat in an ongoing story that spans billions. You move into areas where the density of gas and dust starts to rise. There are star-forming regions where gravity has gathered cold molecular clouds into massive, turbulent structures. Within these, pockets of gas collapse under their own weight, heating up until nuclear fusion ignites and newborn stars shine through their dusty cocoons. Some of these regions would be visible from Earth as glowing nebulae, bright patches in the Milky Way where starlight excites the gas and makes it fluoresce in colors we can capture with telescopes. Others are dark nebulae, blocking the light behind them and appearing as ink-black gaps in the star fields. In these environments, the cycle of stellar life quietly continues. Massive stars live fast, burning through their fuel in just a few million years before ending in supernova explosions. Smaller stars, more like our Sun, live longer, shining steadily for billions of years. Their light, combined with the glow of gas and the faint whisper of dust, creates the subtle texture we see as that hazy band overhead. As you pass through, the view around you becomes richer. More stars per patch of sky, more subtle patterns of light and shadow formed by interstellar clouds. By the time you have traveled about 5,000 light-years from Earth, 5,000 years have gone by on the world you once called home. You are now deep within the Orion Arm structure, having crossed a large portion of the local environment that surrounds the Sun. The Milky Way no longer feels like a distant backdrop. It feels like the environment you reside in, a vast but continuous medium made of stars, gas, dust, and dark matter. The Sun is now just 1 point far behind you, utterly indistinguishable from the myriad stars that fill the darkness. Through all of this, the pace remains gentle. There are no sudden jumps or abrupt changes, only gradual shifts in density, brightness, and the character of the space around you. Gravity has arranged everything on enormous scales. Star clusters bound together, spiral arms slowly rotating, and the entire disk of the galaxy turning around its center over hundreds of millions of years. As you continue this quiet inward journey, further and further from Earth, you are moving not just through space, but through time, measured in light years traveled, and years passed on the planet where your journey began. As you continue drifting forward, the last wisps of the dense star-forming regions fade behind you, like gentle clouds dissolving in the distance. The Orion Arm grows thinner, quieter, and more spacious once again. Here, the stars are still neighbors, but they are spread farther apart, each one with its own history, its own planets, its own invisible cocoon of influence. The familiar textures of our local spiral environment are slowly falling away, and ahead, the galaxy begins to reveal more of its grand structure. This is the natural moment when we leave the first stage of our journey and slip calmly into the second. A deeper voyage through the broader Orion Arm itself, through the sprawling, luminous environment our sun calls home. As the transition unfolds, you might imagine yourself gliding into a more open region of space, where the faint glow of distant nebulae paints soft, blurred strokes across the dark. Here begins the next chapter of the journey, where the Orion Arm's architecture becomes clearer, and the distances from Earth grow vast enough that human time and galactic time begin to drift even farther apart. You are now traveling through the wider stretch of the Orion Arm. This part of the galaxy is rich with diverse stellar environments. Clusters of young, hot stars, old red giants drifting alone, and intricate networks of dust lanes weaving between them. The stars here are arranged along gentle, curving patterns shaped by the spiral density waves that sweep slowly through the Milky Way. These waves compress gas and dust as they move, creating pockets where new stars ignite, while older stars drift onward, aging and cooling over millions or billions of years. At this stage, you are roughly 2,000 light-years from Earth, and 2,000 years have passed back home. To the people of Earth, this amount of time would be enough for entire civilizations to rise and fall, yet to the galaxy, it is negligible, a mere flicker within an ongoing story billions of years long. The Orion Arm continues to stretch around you, a vast, spiraling ribbon of stars, so large that even after traveling this far at light speed, you still remain within the same overarching structure that cradles the sun. Drifting through this region, you encounter dark molecular clouds so massive they form outlines against the background starlight. These clouds are cold and dense, the birthplaces of future stars. Their shapes shift slowly under the influence of turbulence and gravity, sculpted into elongated filaments and delicate sheets. Within them, gravity works with patient persistence, pulling molecules together into cores that will one day flare into new suns. If you could pause and watch over millennia, you would see these clouds swirl, collapse, and finally flare with the ignition of new starlight. Elsewhere in this part of the Orion Arm, young clusters glitter with brilliant blue and white stars, hot, luminous giants that burn fiercely and live briefly. Some of these stars send powerful winds into their surroundings, carving out bubbles and creating shock fronts that ripple through space. Others illuminate the gas left behind from their birth, causing it to glow with soft hues of pink, red, and violet. Even though the galaxy's interior motions are slow, these regions pulse with energy and transformation, small-scale dramas playing out over millions of years. As you continue forward, stellar densities shift, from areas rich in newly formed stars to quieter stretches where older stars dominate. In these more peaceful zones, red dwarfs flicker faintly, their light steady and cool. These stars live the longest of all, potentially trillions of years, far beyond the eventual fading of larger, brighter suns. Many of them host planetary systems, hidden from your view but inferred through the tiny gravitational tugs they exert on their star's light. After a gentle, unhurried drift through these environments, you reach the point where you are now about 5,000 light-years from Earth. 5,000 years have passed on the planet you left behind. Entire eras have unfolded since your departure. Landscapes have shifted. Stars in Earth's night sky have moved ever so slightly in their positions, changing constellations in ways no living human would notice in a single lifetime. Yet from the perspective of the Milky Way, the Orion Arm remains virtually unchanged, still guiding its streams of stars, still nurturing clouds, still rotating slowly around the galactic center. And even here, 5,000 years from home, you are still within the familiar embrace of the Orion Arm, but deeper now, and closer to the great interior of the galaxy. The stars ahead begin to grow subtly denser, and the faint glow of more distant structures begins to shimmer with greater clarity. You can sense, in the soft gradients of the starlight around you, that the next phase of your journey is approaching, the gradual transition toward the inner regions where the galaxy becomes richer, older, and more tightly bound by gravity. But for now, you simply drift, calm and steady, through the wide, spiraling arm of stars that has held our sun for billions of years, one quiet moment at a time. As we drift onward, the memory of the solar system softens behind us, becoming little more than a pale shimmer, an origin rather than a place. The darkness ahead feels deeper now, stretched across a widening gulf where familiar constellations begin to warp and rearrange. We have crossed into a realm shaped not by planets or asteroids, but by the vast tides of interstellar space. And with that gentle shift, we begin the next stage of our voyage, the long, quiet passage through the local interstellar cloud. Here, the emptiness becomes almost meditative. At the speed of light, we slip between wisps of tenuous gas, mostly hydrogen, some helium, and traces of heavier elements, too diffuse to feel, too sparse for the eye to detect. This cloud, the one the sun itself is traveling through at this very moment, spans roughly 30 light-years. It is not a stormy place or a turbulent one, but rather a quiet fog drifting between the stars, shaped by long-forgotten supernovae and the slow currents of the galactic neighborhood. Even at light speed, these distances are patient ones. As we travel through these thin strands of interstellar material, more than 30 years pass on Earth, an entire generation watching the skies turn, the seasons shift, and the slow march of time unfold. For us, this journey feels like a single, unbroken glide. For those back home, it is an era. Within this cloud, stars remain scattered, far apart, each separated by light years of silence. Yet we can sense their distant warmth. Proxima Centauri, Alpha Centauri A and B, Barnard's star, small embers in the surrounding night. Their faint glow reminds us that the Milky Way is not empty. It is filled with quiet stories, each star a furnace of nuclear fire, each system its own possible cradle for worlds. As we continue, subtle changes accumulate. The density of interstellar dust shifts. The faint background radiation fluctuates. And ahead, we begin to feel the pull of something larger, something that is not just local but structural. The long, sweeping form of one of the Milky Way's great spiral arms. We are leaving the quieter outskirts of the Orion Arm's interior and approaching its grander scaffolding, where clusters and nebulae gather like islands in a cosmic sea. Another 50 light-years slip behind us. Another 50 years pass on Earth. A century in total since we first set out. Back home, new generations have been born, entire lifetimes unfolding under the same night sky we once looked up at. And yet here, in this serene river of interstellar material, time feels almost still. Ahead, the stars brighten. Patterns shift. Dust thickens. The faint, vast glow of the Orion Arm rises like a shimmering shoreline welcoming us inland. With a gentle breath, we allow ourselves to drift onward, deeper into our galactic home, toward the next chapter of our journey. As we move gently onward, the quiet haze of the local interstellar cloud thins behind us, and a subtle shift takes hold, like drifting from open ocean toward a luminous coastline. The Orion Arm, once a distant structure, now unfolds around us in fuller detail. Stars begin to grow more numerous. Their light, still far but undeniably richer, forms a soft, grainy glow against the black. We are approaching a realm where stars are not merely present, they are born. This portion of the Orion Arm is sculpted by vast reservoirs of gas and dust, the raw material from which new suns ignite. Here, immense molecular clouds stretch across tens, even hundreds of light years. Their interiors are cold and dark, but within those shadows, gravity works slowly, steadily, gathering matter into denser pockets that will one day flare into brilliant, newborn stars. Our first major stop in this region is the Orion Molecular Cloud Complex. At light speed, the journey here, roughly another few hundred light-years, takes centuries from Earth's perspective. Generations rise, civilizations shift. Entire chapters of human history turn over before we arrive at this celebrated nursery in space. For us, though, it feels like only the next deep breath in a steady, dreamlike glide. As it grows near, the familiar symbols of the night sky take on new meaning. The 3 stars of Orion's belt align with a clarity impossible from Earth. Below them, the Orion Nebula unfurls, a bright, glowing cavern carved into the surrounding darkness. This nebula is one of the closest star-forming regions to our planet, and from within it, newborn stars illuminate the gas with radiant ultraviolet light. The cloud seems to pulse with slow energy, as though inhaling and exhaling on timescales far beyond human perception. We drift closer, feeling more like visitors to a sacred place than travelers passing through. The trapezium cluster, 4 young, massive stars, burns fiercely at the nebula's heart. Their combined radiation sculpts the surrounding gas into curls, ridges, and vast open cavities. Here, stars are measured not in billions of years but in millions, their youth still etched into every shimmering tendril of gas. Moving deeper into this region, we slip past Bok globules, small, cold pockets of dense dust where young stars are still forming, hidden from view. Their shapes drift like dark, rounded silhouettes, each harboring a secret future sunrise. These globules remind us that star birth is not a sudden event but a quiet process, often unfolding in total darkness until ignition finally reveals what gravity has patiently assembled. As we continue along the arm, the Great Barnard's Loop arcs across the sky, an enormous ring of gas spanning hundreds of light years. It is the remnant of ancient stellar explosions, vast supernovae that once enriched the region with heavier elements. These elements, forged in the hearts of long-dead stars, now feed the next generation of celestial growth. Even out here, far from Earth, we see the cyclical nature of the galaxy. Destruction giving way to creation, silence giving rise to light. More light years pass beneath us, hundreds more, flowing like a gentle current. From Earth's frame of reference, nearly 1,000 years slip by as we traverse this fertile region of the Orion Arm. Human history advances through eras. Languages evolve. Cultures rise and fall. But here in the galactic nursery, time moves to an ancient rhythm, unchanged by the flickering of civilizations. Eventually, the density of newborn stars eases. The gas clouds thin. Their brilliant nebulosity fades into quiet, diffuse light. We emerge from the heart of the star-forming regions and drift toward the broader roadway of the arm itself. And as we leave those glowing cradles behind, we sense the next chapter calling, deeper into the spiral arm, where clusters grow older, stars more settled, and the galaxy begins to reveal its grander, sweeping structure. As we ease away from the bright nurseries of the Orion Arm, the scenery begins to shift once more. The swirling clouds of gas grow thinner, their colors dimming into quiet traces. The newborn stars, so young, so radiant, fade behind us like lanterns marking a distant shoreline. Ahead, the galaxy stretches inward, and its scale begins to feel different. Heavier, more intricate, and more ancient. We are approaching the vast interior structure of the Milky Way, where the graceful spiral arms gradually tighten and the first hints of the galactic bar begin to emerge. The bar is not a solid object but rather a grand, elongated concentration of stars, tens of thousands of light years long, rotating slowly at the galaxy's core. From Earth, hidden behind veils of dust, this structure is difficult to see. But from our vantage point, gliding far above the thin plane of the arm, its shape becomes unmistakable. A glowing spindle of densely packed stars, aligned like a bridge between spiral arms and the central bulge. Reaching this region from the Orion Arm requires crossing several thousand light-years of inter-arm space. At the speed of light, thousands of years pass on Earth. Civilizations rise, falter, recover. Continents reshape politically, cultures evolve, and entire epics unfold, all while we continue in a single, smooth, uninterrupted journey. For us, the passage feels like a gentle drift, each star slipping by with patient grace. As we close the distance, we begin to sense the galaxy's growing complexity. The stars become more numerous, not yet the packed brilliance of the core, but far more than in the quiet outskirts we've left behind. Their light blends into a soft, diffuse luminosity, giving this region a subtle golden tone. Many of these stars are older, their light steadier and slightly redder, shaped by billions of years of burn and decline. They form the outer reaches of the bar's influence, where the gravitational patterns begin to twist and guide stellar orbits into elongated paths. Interstellar dust thickens again. Some of it gathers into long, cold lanes running parallel to the bar's length. These dust lanes are like the braided highways of galactic dynamics, regions where gas is compressed as it flows inward, slowly feeding the galaxy's central regions. They stretch like faint shadows across the luminous backdrop of stars, subtle but immense. We drift along these broad corridors, passing clusters of older stars whose orbits are no longer neatly circular. Here, stars move in slightly stretched orbits, pulled and guided by the bar's gravitational pattern. This region has a different mood, less chaotic than the star-forming nurseries, but more directional, as though the galaxy is gently steering its contents toward the center. Through the dust, we glimpse vast clouds of gas being funneled inward. They are not as bright or as active as the Orion complex, but they are essential. The raw material that will one day fuel star formation near the core, or fall even deeper toward the grip of the supermassive black hole at the heart of the Milky Way. Everything we see here flows with purpose, following long, slow river-like currents shaped by the galaxy's inner architecture. As we move closer to the bar itself, the stars thicken into a crowded, shimmering field. Distances between them shrink. Their collective glow becomes almost textured, as though we are drifting through a soft ocean of starlight. Each motion we make seems to trail faint reflections across the surroundings. Even at light speed, the grandeur feels unrushed, timeless, steady, and vast. By now, several thousand years have passed back on Earth. The world that once watched us depart has changed beyond recognition. But here, in the deep interior of the Milky Way, time feels suspended. The galaxy rotates, but slowly. The bar stretches onward, ancient and immense. And ahead, just beyond its luminous edge, awaits the next stage of our journey, the threshold of the central bulge, where the light of billions of stars begins to gather and the true heart of the Milky Way starts to take shape. As we continue drifting inward, our path follows the gentle pull of countless gravitational threads, each guiding us closer to the Milky Way's ancient heart. The bar region gradually thickens behind us, its elongated glow tapering into something rounder, denser, and far more radiant. Slowly, almost imperceptibly, the galaxy begins to rise around us, not just as scattered stars or luminous strands of gas, but as a swelling, three-dimensional brilliance. We are entering the galactic bulge, the vast inner sphere of stars that surrounds the central core of the Milky Way. The transition is not abrupt. It feels more like stepping from twilight into dawn. At first, the star density increases subtly. Points of light appear more frequently, scattered evenly across the sky like grains of gold on velvet. Then, as we move deeper, another few thousand light years, another few thousand years passing silently on Earth, the brightness grows. Stars gather in layered shells, overlapping halos, and soft, glowing tides. Their combined light creates a warm, diffuse radiance that illuminates the region around us more fully than any other part of the journey so far. Here in the Bulge, we encounter some of the oldest stars in the entire galaxy. Many are more than 10 billion years old, forged during the Milky Way's earliest bursts of star formation. Their light is faintly reddish, softened by age and the gradual burning of their hydrogen fuel. They drift in complex orbits, some nearly circular, some elongated, some tilted far above or below the galactic plane. These motions create a mesmerizing dance, a swirling, ancient ballet that has continued for eons without pause. The Bulge is enormous, spanning more than 10,000 light-years across. It is a structure of immense mass and quiet authority, its gravitational influence shaping the motions of the inner galaxy. As we drift through it, the sheer number of stars becomes almost impossible to comprehend. There are billions here, each one a sun, each one with its own potential histories, its own past companions, its own chemical memories etched into its light. We glide past tightly bound globular clusters, great spherical gatherings of hundreds of thousands of stars compressed into tiny volumes of space. They orbit the Bulge like ancient satellites, relics of a time when the galaxy was young and chaotic. The stars within them shine with a pristine, icy quality, old, metal-poor suns that have changed little since their formation. Each cluster feels like a fossil suspended in space, holding secrets from the galaxy's earliest chapters. Between these clusters lie vast stretches of interstellar dust, thicker here than in the spiral arms. These dense clouds absorb starlight, creating dark, curving lanes that cut across the Bulge like brushstrokes of shadow. Even so, the radiance of billions of stars filters through, glowing softly like distant lamps behind a curtain. The interplay of dust and light gives the Bulge a rich, textured appearance. Mottled gold, deep amber, and occasional hints of crimson where denser clouds obscure the stars behind them. If we pause in our drift, just for a moment, the view becomes overwhelming in its depth. In every direction, stars fill the sky. There is no darkness here, no empty expanse like the one we crossed in the interarm regions. Instead, the sky resembles a living mosaic, each point of light a reminder that the galaxy's core is not a single feature but a grand, layered system built over billions of years. Traveling at the speed of light, thousands more years pass on Earth as we journey through the Bulge. The entire span of recorded human history flashes by back home many times over. Yet here, the stars age barely at all. These suns have seen the galaxy rise from turbulent youth to mature structure. A few millennia are nothing to them. Their constancy becomes soothing, a quiet reassurance that the cosmos moves on scales far more patient than anything humans experience. Occasionally, we glide near regions of renewed activity, areas where gas has pooled and compressed, igniting new bursts of star formation even here in this old stellar realm. Small nebulae glow with pinkish hydrogen light. Newborn stars, hot and blue-white, flicker like sparks within the haze. Even in this ancient place, creation has not ceased. The Bulge is not a relic frozen in time. It is a living component of the galaxy, changing slowly but continuously. As we venture deeper, we begin to sense a shift in the gravitational field. A faint tightening, a subtle deepening. It is the pull of something immense, something that dominates the innermost few light years of the Milky Way. Stars around us start to move in more eccentric paths, swirling in complex, looping patterns. Their speeds increase. Their orbits become more chaotic, influenced by a mass so dense and powerful that even from this distance, its presence is unmistakable. The sky grows brighter, more crowded. Dust thickens, light bends, and the motions of nearby stars grow faster, like fireflies circling a hidden flame. We are nearing the very center of the galaxy, where the Bulge narrows into a dense, brilliant core. Ahead, still veiled in layers of dust and starlight, something waits. Not a destination exactly, but a gravitational landmark so profound it anchors the entire Milky Way. We drift toward it gently, carried by the natural flow of the inner galaxy, ready for the next stage of our journey, the approach to the central few light years, where the motions of stars themselves reveal the presence of an extraordinary and mysterious force at the heart of our cosmic home. As we leave the outer reaches of the bulge behind, the stellar glow begins to intensify, and the density of stars rises to an almost overwhelming level. The galaxy feels different here. The air of serenity we carried through the spiral arms and the older parts of the bulge now deepens into something more intense. A vibrancy born of compressed matter, turbulence, and the immense gravitational pull toward the galactic center. We are entering the Central Molecular Zone, or CMZ, a region that is, in a way, the beating heart of the Milky Way's inner structure. The CMZ is vast yet tightly confined, spanning roughly 1,000 light-years across, and within it lies a concentration of molecular gas so dense it would be incomprehensible at a glance. Here, the clouds are enormous, each one containing tens of thousands to millions of times the mass of our Sun. They are thick, cold, and turbulent, swirling in a slow but persistent dance driven by gravity, rotation, and the shocks of stellar activity. Unlike the calm, sparse interstellar regions we traveled through earlier, this space pulses with quiet energy, the hum of cosmic processes that will take millions of years to unfold, but that define the inner workings of the galaxy. As we drift along, the view is textured with both darkness and light. Dense molecular clouds, opaque to visible light, appear as shadowy shapes against the brighter backdrop of older stars in the bulge. Between these clouds, ultraviolet light from young, massive stars escapes, illuminating surrounding gas and creating patches of faint, iridescent glow. The contrast is mesmerizing. Pockets of darkness harboring raw material for new stars, set against the radiance of older stars and glowing nebulae. These clouds are not still. They move and twist, compressed and sheared by the galactic bar's gravitational forces, forming filaments, arcs, and dense knots of potential stellar birth. Within the CMZ, the pace of stellar evolution quickens relative to the older bulge. Massive stars flare into life and die in supernova explosions in just a few million years, leaving behind shockwaves that ripple through the surrounding gas. These shocks compress nearby clouds, triggering further rounds of star formation, a process repeated over and over across the CMZ. If we could pause and watch over millions of years, we would see regions of gas light up with newborn clusters, then fade as their massive stars end their brief but brilliant lives. This is a living, dynamic environment, a place where creation and destruction exist in balance, quietly shaping the future of the galaxy. As we glide deeper, we notice some of the most famous structures of the CMZ. Sagittarius B2, one of the largest molecular clouds in the Milky Way, so massive that it contains enough material to form tens of thousands of stars like our Sun. Its interior is turbulent, its density so high that even photons struggle to escape. Nearby, other clouds stretch in arcs along the plane of the galaxy, their motion sculpted by both gravity and the rotation of the inner bulge. Streams of ionized gas flow through gaps between the clouds, glowing faintly in radio and infrared light. Invisible to our eyes but detectable through careful observation, these streams carry material inward, toward the innermost reaches of the galaxy. The CMZ is also home to unusually young and massive star clusters. In contrast to the older stars of the bulge, these clusters shine fiercely, their hot blue stars emitting intense ultraviolet light that carves cavities in the surrounding gas. The radiation and stellar winds from these clusters act as a sculptor's hand, shaping clouds into delicate arcs, pillars, and shells. Every newborn star here is a bright, transient flare against the quiet depth of older stellar populations, a reminder that even the galaxy's heart is alive with ongoing creation. Traveling at the speed of light, several thousand years pass on Earth as we move through this compact, crowded, and turbulent region. Civilizations come and go, empires rise and fall, but here in the CMZ, time seems suspended. The clouds swirl, stars flare, and gravity pulls patiently, as it has for millions of years. There is a rhythm here, subtle and slow, yet persistent, a quiet pulse at the galaxy's center. We drift past the outer fringes of Sagittarius A West, the so-called mini-spiral of gas near the very core. Streams of ionized material spiral inward, influenced by the supermassive black hole at the heart of the galaxy. Though distant at first, its presence is already shaping the dynamics of the CMZ. Stars orbit in intricate paths, their velocities reflecting the gravitational weight of something vast and invisible. Even here, far from the actual black hole, the influence of gravity is undeniable, bending the orbits of gas and stars alike into a coherent, if complex, pattern. The CMZ is a landscape of contrasts. Ancient stars drift slowly through dense, chaotic clouds. Massive, brilliant clusters illuminate their surroundings while shadows of molecular gas loom ominously nearby. Turbulent motion exists side by side with gentle rotation. And all of it is directed inward, a subtle funneling of matter toward the very heart of the galaxy. As we continue, we sense the space ahead becoming even more tightly packed. Stars grow closer together, their motions faster and more intricate. Clouds become less extended and more fragmented, their paths warped by gravitational currents. Dust and gas swirl in a denser, more chaotic symphony. We are approaching the threshold where the CMZ blends into the innermost few parsecs of the galactic center, a region of extraordinary density, where the dynamics of stars and gas are dominated by the unseen yet immense force at the galaxy's heart. And so, with gentle motion and steady reflection, we drift onward, deeper into the central molecular zone, feeling both the weight of the past and the quiet promise of creation, preparing ourselves for the next stage, the intimate, dynamic environment that surrounds the supermassive black hole itself. As we glide inward from the central molecular zone, the scale of the galaxy begins to compress in a way that is almost tangible. The broad, diffuse glow of billions of stars tightens into a more concentrated, almost jewel-like brilliance. Here, the galaxy feels alive in a different way, less diffuse, less serene, and more immediate. The stars are no longer scattered across vast distances, drifting slowly through interstellar gas. Instead, they orbit rapidly, weaving intricate paths around a hidden center whose gravity dominates every motion. We have now entered the inner few parsecs surrounding Sagittarius A*, the supermassive black hole at the Milky Way's heart. The first thing we notice is the density. Stars are no longer separated by light years but by mere fractions of a light year. The night sky is filled with countless points of light, each one seemingly suspended in a three-dimensional lattice. Their motion is noticeable even at our imagined light-speed journey. Some stars orbit in almost perfect ellipses, tracing paths that would take decades, centuries, or millennia to complete. Others follow more chaotic, looping trajectories, the result of gravitational interactions with their neighbors and the overwhelming pull of the central mass. Within this region, a special population of stars dominates the view. The S-stars, a group of young, hot stars orbiting within a few light days to light years of the black hole itself. Despite the intense gravitational forces, these stars are remarkably resilient, shining with a brilliance that is visible even through the thick layers of surrounding dust. Their orbits are tightly monitored by astronomers on Earth, revealing with astonishing precision the mass and location of the black hole they circle. We drift among them now, seeing their rapid motions as a ballet of gravity and light, each trajectory an elegant curve in the dark. The environment is extreme in other ways, too. Gas clouds spiral inward along complex paths, tugged and stretched by tidal forces. Some clouds are compressed into thin, elongated filaments, glowing faintly as collisions within them excite molecules to emit infrared light. Stellar winds from the nearby hot stars whip through these filaments, creating shocks and turbulence. Occasionally, Compact clusters of newly formed stars are embedded within these clouds, their energy slowly carving cavities into the surrounding gas, sculpting the environment like a patient artist. As we drift deeper, the gravitational influence of Sagittarius A becomes more pronounced. Stars near the center orbit with astonishing velocities, hundreds or even thousands of kilometers per second, moving in tightly bound paths that spiral in intricate arcs. Time itself, from the perspective of these orbits, begins to feel warped. Einstein's theory of general relativity becomes more than a concept here. The immense gravity subtly bends the trajectories of light and matter alike, creating phenomena that would appear almost impossible if viewed from Earth without precise instruments. Despite the chaos and density, there is a rhythm. Stars orbit, clouds flow, and the gravitational pull of the black hole organizes these motions into patterns that persist over thousands of years. This region, though violent and crowded compared to the calm expanses of the Orion Arm or even the outer Bulge, possesses an elegance born of extreme order. Everything here is bound to the same unseen center, everything moving in response to the same fundamental force. Embedded within these inner parsecs are also remnants of earlier stellar evolution. Supernova remnants punctuate the region, their material contributing heavy elements to the environment. These metals enrich the surrounding gas, seeding future generations of stars. Here, even death contributes to creation. The mix of young, massive stars and the debris of ancient, exploded ones creates a dynamic, living ecosystem of matter and energy. We notice subtle, almost invisible currents of matter, streams of ionized gas spiraling inward, their paths governed by the combined pull of the black hole and the orbiting stars. These streams glow faintly in infrared and radio wavelengths, carrying gas that may eventually accrete onto the black hole itself. Each particle of gas is caught in a cosmic choreography, moving along paths defined by the immense gravity at the galaxy's heart. At this distance, the passage of time on Earth is staggering. Tens of thousands of years could pass in the blink of our journey, yet the motions of these stars and gas clouds remain consistent, predictable, almost hypnotic. The scale of patience here is unlike anything we experience on our home planet. We begin to understand that the center of the Milky Way is both violent and delicate, chaotic yet orderly, a place where extremes coexist in subtle balance. As we move closer, the density of stars increases further. Their combined gravitational fields interact, creating tiny ripples and oscillations in the orbits of nearby neighbors. Occasionally, two stars pass close enough to perturb one another, sending one into a new elliptical path or nudging it toward the black hole's influence. These interactions are rare, but over millennia, they accumulate, subtly reshaping the architecture of the inner parsecs. We also glimpse dark silhouettes against the luminous backdrop, clouds so dense and thick they obscure light, yet from Earth, they can only be detected indirectly through infrared and radio observations. Within these shadows, material may be slowly spiraling inward, feeding both star formation and the central black hole. The contrast of dark and light, of motion and stillness, creates a stunning three-dimensional tapestry, woven from both matter and energy. Everywhere we look, there is motion. Nothing is stagnant here. Stars, gas, and dust move in interlaced rhythms, following paths defined by gravity, momentum, and the shape of the central potential. The environment is harsh, extreme, and unforgiving, yet it possesses a strange beauty, an ordered chaos, perfectly tuned over millions of years. As we continue drifting through the inner parsecs, it becomes clear that this is the stage where the galaxy's story converges. Every star, cloud, and particle is participating in a gravitational dance around a singular, dominant presence. And that presence, Sagittarius A*, awaits ahead, invisible yet undeniable, anchoring the motions of everything we see. We move closer, calm and patient, absorbing the immense scale, the dense brilliance, and the delicate interplay of forces. Here, In this intimate, crowded, and extraordinary environment, we are witnessing the very dynamics that define the Milky Way's core, a prelude to the final approach toward the supermassive black hole that anchors our galaxy and shapes the fates of everything around it. You drift ever closer to the heart of the Milky Way, carried along by the gentle pull of gravity, as if riding an invisible current across a vast, dark sea of space. Around you, stars grow denser, their light overlapping and blending into a soft, luminous haze. These are not scattered points across the void but a concentrated population, tracing intricate orbits around an invisible center. You have entered the innermost parsecs surrounding Sagittarius A*, the supermassive black hole at the galaxy's core, a place where the fabric of space itself bends and twists under immense weight. At the center lies the black hole, a compact mass roughly 4 million times the weight of our Sun. Its gravitational influence dominates every motion nearby, shaping the orbits of stars, the flow of gas, and even the paths of photons as they bend around the unseen singularity. You begin to notice the first of the S-stars, a collection of young, hot, and massive stars. Their orbits are sharp and elliptical, some passing perilously close to the black hole before swinging outward again, tracing paths in the dark that are as precise as they are astonishing. The closest of these stars may approach the black hole within just a few light days, moving at speeds of thousands of kilometers per second. Their youth and energy defy expectation, for the black hole's tidal forces should, in theory, make star formation nearly impossible in such proximity. Yet here they are, radiant points of blue-white light, orbiting with breathtaking speed and grace. As you glide among them, the space is alive with motion. The stars move not in isolation but in relation to each other, tugging subtly at neighbors, occasionally nudging gas clouds, and contributing to the dynamical dance that defines this region. Stellar orbits vary widely. Some trace nearly perfect ellipses, a predictable path choreographed by gravity. Others loop and curve in more chaotic trajectories, influenced by close encounters with neighboring stars or subtle perturbations from the gravitational field itself. Time here is strange. From the perspective of Earth, thousands of years pass as you drift, yet the stars follow their orbits in perfect, enduring rhythm, barely affected by the passage of millennia outside this region. Amidst these stars, the environment is threaded with gas, plasma, and dust. Streams of ionized material flow along complex trajectories, spiraling inward, twisting and stretching under the influence of gravity and magnetic fields. These streams glow faintly, a gentle infrared light against the deep black of space. Some filaments are dense, compressed by tidal forces into long, thin tendrils. Others are more diffuse, spreading across the sky like misty clouds. Within these flows, particles are accelerated to near relativistic speeds, spiraling along magnetic field lines, radiating energy that flickers and pulses as they move. Flares erupt intermittently, tiny sparks of brilliance against the dense backdrop of stars and gas. These flares occur as pockets of plasma orbit close to the black hole, heated and energized by magnetic reconnection events. The light they emit flickers, brightening and fading over minutes, tracing the motion of matter in a near orbit around the event horizon. The orbits themselves are not ordinary. The immense gravity distorts them subtly, causing precession, warping, and effects that can only be fully explained by general relativity. Each flare is a delicate, transient beacon, revealing the hidden choreography of the black hole's immediate vicinity. Despite these bursts of activity, Sagittarius A* remains relatively faint compared to the energetic nuclei of some other galaxies. Only a fraction of the gas drawn toward it ultimately crosses the event horizon. Most of the matter in these inner parsecs is caught in a delicate balance. Some streams accrete inward, feeding the black hole over centuries and millennia, while others are redirected or expelled, never completing their inward journey. You drift past these flows, feeling the subtle motion of gravity and magnetism shaping the structure around you. Even in apparent chaos, there is order. As you approach closer, the density of stars increases further. Supernova remnants, remnants of massive stars that exploded long ago, punctuate the environment. Their material mixes with surrounding gas, enriching it with heavier elements, which in turn influence cooling, condensation, and the potential for future star formation. Stellar winds from massive young stars carve cavities in clouds, sculpting the gas into pillars, arcs, and shells. The interplay of birth and death is constant. Creation and destruction coexist seamlessly in this cosmic ballet. Magnetic fields dominate the behavior of ionized gas. They guide charged particles along curved paths, twisting and folding in spirals and arcs. Occasionally, the field lines snap and reconnect, releasing bursts of energy, heating plasma, and generating flares. You observe the plasma flowing along these invisible highways, tracing paths dictated as much by magnetism as by gravity. Each current, each flare, is part of a larger, self-consistent structure that persists over millennia. The gravitational influence of the black hole affects light as well as matter. Photons passing near the event horizon bend along curved trajectories, creating subtle distortions, magnifications, and lensing effects. Some light takes longer paths, curving around the mass before reaching your vantage point, while others are slightly red-shifted as they climb out of the deep gravitational well. Every photon you see carries information about the curvature of space-time, bending to reveal the hidden structure of gravity at work. Embedded within this turbulence are pockets of new star formation. Though rare, even in these extreme conditions, gas can collapse locally, forming massive, hot stars that shine brightly against the dense stellar background. These stars orbit the black hole in tight, elliptical paths, adding new points of brilliance to the ever-changing tapestry of the inner parsecs. The inner environment is a place where extremes coexist. Stars move at tremendous speeds. Gas is compressed and energized. Magnetic fields twist and release energy. Space itself curves in ways that defy everyday intuition. Yet within these extremes, patterns emerge. Orbits repeat, flares flicker with periodicity, gas flows along coherent paths. There is a rhythm here, subtle and slow, a pulse dictated by gravity and magnetism alike. Some stars experience close encounters, their orbits perturbed as they pass near one another. Occasionally, a star may be nudged onto a trajectory that brings it perilously close to the black hole. In such cases, tidal forces can stretch and distort it, a slow, invisible strain that is profound yet imperceptible on human timescales. Even the smallest deviations, repeated over centuries, contribute to the ongoing dynamical evolution of the inner parsecs. The black hole itself remains unseen, its presence inferred entirely through gravitational influence. Its event horizon marks the boundary beyond which nothing can escape, not even light. Surrounding this horizon is the innermost stable circular orbit, a region where matter can orbit in a delicate, stable balance before succumbing to the pull of the abyss. Plasma near this boundary moves at extraordinary speeds, its light tracing elliptical paths that flicker and shift, revealing the extreme curvature of space-time. Magnetic reconnection events, plasma flows, and relativistic effects combine to create a constantly changing environment. Hotspots orbit near the event horizon, flares appear and fade, gas streams spiral inward, and stars trace their intricate elliptical paths. The sky is alive with motion, yet there is a quiet consistency. Every orbit, every flow, every flare follows the laws of physics, creating a dynamic equilibrium that is both chaotic and serene. As you drift further, the density of stars and gas continues to increase. The interplay of gravitational forces, magnetic tension, and relativistic effects becomes more intricate. Streams of gas twist and spiral, some accreting onto the black hole, others diverted outward by magnetic or gravitational forces. Stellar winds carve cavities, flares punctuate the darkness, and the motions of stars create subtle ripples in the gravitational field. The passage of time is both rapid and slow. From Earth's perspective, thousands of years may pass as you drift, yet the motions here persist with astonishing consistency. Stars orbit, plasma flows, magnetic fields twist, and flares erupt in a continuous cycle. The inner parsecs are a living laboratory, a dynamic environment that illustrates the extremes of gravity, velocity, density, and magnetism in perfect balance. Here, in the immediate vicinity of Sagittarius A*, you experience the Milky Way's heart in its full complexity. Stars orbit with incredible speed, gas flows along magnetized paths, flares flicker in transient brilliance, and gravity bends the very fabric of space. Extremes coexist: chaos and order, violence and serenity, youth and age, all bound together in the immense gravitational field of the black hole. Floating in this dense, luminous, and dynamic space, you witness the structure, the motion, and the forces that shape our galaxy. Every photon, every orbit, every flare carries the signature of gravity and magnetism, revealing the intimate workings of the galaxy's core. The environment is alive, intense, and breathtakingly beautiful, a place where the Milky Way's story converges into a single, commanding center. As you approach ever closer to the event horizon, the drama of motion, light, and gravity intensifies. The orbits of stars become more tightly wound, flares orbit faster, and the curvature of space-time more pronounced. Here, at the threshold of the black hole, the Milky Way's story narrows to a point of unimaginable density, where gravity dominates all, and the dance of stars and matter is governed by forces both violent and precise. The region is at once extreme and meditative. Chaos exists, yet order prevails. Light bends, time dilates, plasma flows, and stars orbit. Every movement is part of a larger, coherent pattern. Even in the violent dynamics near the event horizon, there is a rhythm, a pulse, a cosmic heartbeat that persists across millennia. And as you drift in this quiet, luminous sea, the black hole looms ever closer, a silent, invisible anchor to the motions of billions of stars, streams of gas, and untold photons. Its influence extends outward, shaping the galaxy's core, organizing motion, and preserving the balance that has persisted for billions of years. You are at the center of it all, witnessing the deepest workings of our galaxy, floating in the space where extremes meet, where time and gravity intertwine, and where the Milky Way reveals its most intimate and powerful secrets. After drifting through spiral arms, the central bulge, the dense molecular clouds, and the inner parsecs filled with flaring stars and plasma, we now arrive at the very heart of our galaxy. Here lies Sagittarius A*, the supermassive black hole that anchors the Milky Way, a singular point of immense gravity, hidden yet profoundly present. As we approach, the light, motion, and energy of the surrounding region converge, creating a view unlike anything we have witnessed so far, a space dense with both matter and meaning, where the ordinary rules of perception are subtly altered by the profound curvature of space-time. The first thing we notice is the overwhelming concentration of mass. Sagittarius A* itself is invisible. No light escapes its grasp. Yet its presence dominates everything around it, warping the paths of nearby stars, guiding the orbits of plasma clouds, and bending the very trajectories of photons that attempt to skirt its edge. Its estimated mass is roughly 4 million times that of our Sun, concentrated within a volume so small that the concept of distance loses its ordinary meaning. Every object we observe, the stars, the gas streams, the flares of plasma, is moving in response to this central anchor, tracing arcs and loops that defy intuitive understanding. Surrounding the black hole is the innermost accretion zone, a region where gas and plasma swirl at incredible speeds. Some of this matter orbits just beyond the event horizon, held in delicate balance in what is known as the innermost stable circular orbit. Here, the forces of gravity are extreme, bending time and space itself. Plasma heated by friction and compression glows in infrared, radio, and X-ray wavelengths. Observing it, even in imagination, is to witness a subtle dance of light and matter, where the dynamics are dictated by relativity as much as by classical physics. We see hot spots of plasma, orbiting near the horizon in arcs that complete a full circle in just tens of minutes. These energetic pockets emit radiation that flickers and wavers as they follow their tightly bound paths, each orbit tracing the invisible geometry of space-time. Magnetic fields twist around the black hole, threading through the plasma, guiding charged particles, and occasionally snapping and reconnecting, releasing bursts of energy that flare brightly before fading again into the surrounding darkness. These reconnection events are both violent and delicate, a reminder that even in chaos, nature organizes itself according to elegant laws. Stars in the immediate vicinity orbit at breathtaking velocities. The closest S-stars complete orbits in mere years, approaching the event horizon at speeds approaching several thousand kilometers per second. Each orbit is a precise, gravitationally governed curve, revealing the mass and structure of the central singularity. Observing their motion, we begin to sense the effects of time dilation, a consequence of Einstein's general theory of relativity, where the flow of time is subtly altered by the intensity of gravity. The surrounding environment is not only shaped by gravity but also by magneto-hydrodynamics, the interplay of magnetic fields and ionized gas. The magnetic fields channel plasma into spirals and filaments, constraining its motion, creating arcs, and occasionally launching small-scale outflows away from the black hole. The plasma itself glows faintly, radiating as it spirals inward, carrying both energy and angular momentum. Even though the black hole is comparatively dim, this region is alive with motion, a complex web of matter and energy dancing on the edge of the abyss. Amidst this motion, we notice subtle structures in the gas and dust. Clumps of matter are compressed into arcs and knots, sometimes forming transient shocks as streams collide or interact with magnetic fields. These interactions can trigger rapid heating, particle acceleration, and temporary flares. The environment is a living laboratory of extreme physics. Turbulence, relativity, and magnetism all converge to shape the motions of gas and light in ways that are both predictable and astonishing. We drift closer still, and the bending of light becomes more pronounced. Photons that would otherwise travel in straight lines are deflected along curved paths, forming an intricate tapestry of arcs, lensing effects, and subtle magnifications. Some light completes a near orbit around the black hole before continuing outward, creating faint echoes of its journey. The region is simultaneously chaotic and ordered, violent and serene. Here, the gravitational pull of Sagittarius A* dominates all scales. Stars, gas clouds, and even dark matter particles follow paths dictated by the black hole's immense mass. Occasionally, a star ventures too close, stretched by tidal forces into a long, thin shape, a reminder of the intense gravity at work. Streams of gas spiral inward, some crossing the innermost stable circular orbit and disappearing silently beyond the event horizon, adding their mass to the black hole, while others are redirected outward, expelled by the magnetic and centrifugal forces at play. The plasma itself is fascinating to observe. Hot spots orbit near the black hole, emitting bursts of energy that rise and fall over minutes. These flares, though transient, reveal the nature of extreme gravity, relativistic motion, and magnetic reconnection. Their orbits trace the curvature of space-time, and their light, shifted and stretched, carries information about the environment that surrounds the event horizon. Each flare is a subtle pulse, part of a rhythm that repeats, persists, and changes over time. Even in this extreme environment, new stars can form. Dense clumps of gas collapse under their own gravity, occasionally giving rise to young, massive stars that shine brightly in blue-white light. These stars orbit Sagittarius A * in tight, elliptical paths, adding luminous threads to the fabric of the inner galactic core. Their presence is a testament to the resilience of matter, capable of forming new structures even in the shadow of overwhelming gravity. You notice the interplay of stellar winds and magnetic fields. Massive young stars emit fast, ionized winds that push against surrounding gas, creating cavities and arcs. The magnetic fields twist and reconnect, guiding charged particles and influencing the behavior of plasma. Occasionally, the winds and fields collide with streams of infalling gas, generating shocks that heat the plasma and produce faint flares. It is a subtle, constant interaction, a dialogue between matter and force at the edge of a gravitational abyss. The sky here is densely populated with light. Stars orbit at high speeds, plasma glows, flares erupt intermittently, and photons bend along curved paths. Gravitational lensing magnifies some stars, subtly altering their apparent position. The result is a layered, dynamic view, a tapestry woven from both visible and invisible phenomena, all dictated by the immense pull of the black hole. Time flows differently here. Millennia pass in the span of our journey, yet the orbits, plasma streams, and magnetic structures maintain their rhythm. The inner parsecs are alive with ongoing motion, yet a quiet consistency pervades. Each orbit is precise, each flare predictable in its timing, each plasma stream part of a larger, coherent system. The environment is extreme, yet remarkably ordered, a balance between chaos and law. As we drift ever closer, we sense the singularity itself. The event horizon lies ahead, marking the ultimate boundary. Matter that crosses it vanishes from the observable universe, swallowed silently into the black hole. Yet its presence governs all motion around it, anchoring the orbits of stars, the paths of plasma, and the bending of light. Its influence is invisible but undeniable, the defining force of the Milky Way's heart. Even as we approach this final boundary, the surrounding environment continues its dance. Stars orbit at incredible speeds, plasma swirls in tight spirals, flares flicker and fade, and magnetic fields twist in invisible arcs. The interaction of these forces creates a living, breathing ecosystem at the galactic center, where matter and energy flow, twist, and orbit according to universal laws. Here, at the edge of the event horizon, the Milky Way's story converges. Every spiral arm, every molecular cloud, every star we passed along our journey has funneled matter and energy into this central point. The supermassive black hole anchors the motions of billions of stars and clouds, shaping the galaxy's structure, guiding its evolution, and influencing the future of matter within its reach. The region is both extreme and meditative. Forces of unimaginable magnitude coexist with a subtle, persistent rhythm. Chaos exists, yet order prevails. Stars, gas, and light all move within patterns dictated by gravity, magnetism, and relativity. The environment is violent, yet serene, dynamic, yet consistent. Every photon, every orbit, every flare is part of a vast, interconnected system, a reflection of the Milky Way's enduring structure. Floating here, at the galactic center, you experience a profound sense of connection. This is the heart of our galaxy, a point where time, gravity, and energy converge. Every motion, every flicker of light, every spiral of plasma is part of a cosmic narrative, unfolding quietly, persistently, across millennia. You are witnessing the deepest workings of the Milky Way, the forces that shape its past, present, and future, and the invisible anchor that binds it all together. As we linger, we see that even the most extreme phenomena, the bending of space, the near light speed motion of stars, the flares of plasma, and the tides of gravity, are part of a cohesive, ordered system. Sagittarius A* is both an abyss and a keystone, the ultimate anchor around which the galaxy orbits. Every orbit, every flare, every motion is a testament to the extraordinary balance of forces that sustain our galaxy. Here, at the very edge of the event horizon, we can pause in quiet reflection. The black hole is invisible, silent, and eternal in human terms. Yet its presence resonates throughout the galaxy, shaping stars, clouds, and light in a cosmic dance that has persisted for billions of years. Floating at the threshold, we witness the culmination of a journey across space and time, arriving at the heart of the Milky Way, where matter, energy, and gravity converge in a singular, magnificent point. This is the Milky Way's ultimate center, its pulse and anchor, its deepest secret. And as we linger in this place, suspended between gravity and light, between chaos and order, the story of our galaxy unfolds in all its subtle, overwhelming, and beautiful complexity. And now, as we linger at the very heart of the Milky Way, having traveled from the familiar warmth of Earth, past our sun and neighboring stars, through the spiral arms, across the dense molecular clouds, and finally into the glowing, dynamic core of our galaxy, we pause to reflect on the journey we have taken. We began close to home, drifting past our planet, our moon, and the planets of the solar system, feeling the subtle pull of the sun and noticing the delicate balance that keeps our cosmic neighborhood in harmony. Each planet, each asteroid, each speck of dust was a small but meaningful part of a vast system, orbiting in rhythms as precise and predictable as clockwork, yet alive with complexity. As we moved beyond the sun, the distances grew vast. We passed the nearest stars, their light traveling years to reach us, their motions revealing the gravitational web that binds them. These stars, some solitary, some in binary or multiple systems, reminded us of the diversity of stellar life and the stages of evolution, from young, hot suns to ancient, cooling remnants. We witnessed how gas and dust coalesce to form new stars and how dying stars scatter elements across space, enriching the environment for future generations. Journeying along the spiral arms of the Milky Way, we entered regions dense with star-forming clouds, where gravity, pressure, and turbulence interact to create luminous nurseries. Here, the galaxy hums with activity, quietly yet persistently, forming new suns that will one day host their own systems, perhaps worlds not unlike our own. Each cloud, each filament of gas and dust, is both chaotic and ordered, a delicate balance between collapse and support, driven by forces we can measure and yet can barely imagine in their vastness. As we approached the central bulge, the stars grew closer together, forming a crowded, golden-hued sphere of ancient suns. Here, gravity rules with a stronger hand, orchestrating a complex dance of stars, clouds, and compact remnants. Within this bulge, matter flows in streams, guided by the invisible currents of magnetism and the subtle tug of the central mass. It is a place where the Milky Way's history is encoded in the motions and compositions of its stars, where the echoes of formation and destruction persist in quiet elegance. Crossing into the bar region, we saw the galaxy's structure revealed in sweeping, elongated patterns of stars, twisting like a spiral in slow motion. Here, the gravitational resonance of the bar channels gas inward, feeding the central molecular zone, a dense, dynamic environment of clouds, filaments, and turbulent flows. Within these molecular clouds, star formation continues amid intense radiation and magnetic activity, producing some of the youngest and most energetic stars in the galaxy. As we entered the inner galaxy, the density of stars increased dramatically. The motions of stars became faster, tighter, more intricate, as they responded to the gravitational dominance of the unseen center. Streams of gas, charged particles, and magnetic fields intertwined to create a living, breathing system. Flares of plasma pulsed in rhythmic patterns, orbiting near the innermost regions in a constant, subtle dance. Here, every movement is governed by the combined influence of gravity, magnetism, and relativistic effects, a choreography of extremes that is breathtaking in both its violence and its order. In the central molecular zone, we witnessed gas clouds twisting, colliding, and heating, forming dense knots that could collapse into new stars. Magnetic fields guided the flows, occasionally snapping to release bursts of energy that illuminated the surrounding space. The sky was alive with motion and light, yet calm, as if the entire system pulses with a quiet heartbeat that has persisted for millions of years. Approaching the inner parsecs around Sagittarius A*, we encountered the S stars, moving at incredible velocities along tightly curved paths. The black hole's influence dominates every orbit, bending light, stretching time, and creating subtle distortions in space itself. Plasma orbits, flares erupt and fade, and streams of gas spiral inward or are ejected outward. We saw the Milky Way's extremes coexisting: youth and age, formation and destruction, chaos and order, revealed in every motion, every flicker, every curve traced by stars and light. Finally, at the immediate vicinity of Sagittarius A*, we reached the event horizon, the invisible boundary beyond which nothing escapes. Here, the galaxy converges into a singular, commanding presence. Gravity shapes every nearby object, magnetic fields guide the motions of plasma, light bends in arcs, and time itself is subtly altered. Yet, even in this extreme environment, there is a rhythm, a subtle consistency, a quiet order in the dance of matter and energy. And now, as we reflect on the entirety of this journey, from Earth, across the solar system, past neighboring stars, along spiral arms, through dense molecular clouds, into the galactic bulge, the bar, and finally to the central black hole, we recognize the profound unity and interconnectedness of the Milky Way. Every star, cloud, filament, and particle is part of a system far larger than ourselves, yet intimately connected to our place within it. The Milky Way is alive in its motions, dynamic yet orderly, extreme yet serene. We leave the central black hole with a sense of quiet awe. We have traversed millions of light years in thought and imagination, moving at the speed of light through both space and understanding. We have witnessed the extremes of gravity, the elegance of stellar orbits, the glowing beauty of gas clouds, and the subtle intricacies of magnetic and relativistic phenomena. And in this reflection, we see our galaxy as a living entity, a vast, pulsating system, shaped over billions of years, carrying within it the echoes of creation, the fingerprints of destruction, and the quiet promise of future stars yet to shine. As our journey comes to a close, we return our thoughts to our home planet, small and fragile amidst the grandeur we have witnessed. Yet, in the context of this immense galaxy, our position is not insignificant. Every perspective, every observation, adds to our understanding of the Milky Way's story. From the spiral arms to the central black hole, from the motion of distant stars to the flicker of plasma flares, we have glimpsed the structure, the forces, and the rhythms that define our cosmic neighborhood. In the end, the journey is both outward and inward. Outward through space, toward the center of our galaxy, and inward through reflection, understanding, and appreciation. We have seen the Milky Way's heart, yet we have also glimpsed the beauty of its orchestration, the subtle balance of forces, and the quiet elegance that allows such a vast system to persist. And in this awareness, we find both knowledge and serenity, a reminder that the cosmos is at once immense and intricate, violent and peaceful, unfathomably large, and yet deeply interconnected with our own place within it. As the light of the stars drifts past us, as the plasma continues to swirl and flare, and as the black hole silently commands the motions of its surrounding matter, we feel the profound stillness and activity coexisting, the harmony of forces that has shaped the Milky Way for billions of years. We are small observers, yet part of a vast, intricate system, carried along by currents of gravity, light, and time. And now, as our journey concludes, we carry with us the knowledge of a galaxy alive with motion, history, and mystery. From the first light of our sun to the extreme environment near Sagittarius A*, we have traced the Milky Way's structure, motion, and energy, and in doing so, we have glimpsed both the power and the serenity of our cosmic home. The journey may end, but the galaxy continues to rotate, to form, to collapse, to flare, and to persist, carrying forward its story across eons. So as we drift back from imagination to reality, from the heart of the galaxy to our own quiet homes, we remember that we have touched, even briefly, the pulse of the Milky Way. We have traversed the spiral arms, the clouds, the stars, and the central singularity, witnessing the extremes of physics and the subtle rhythms of the cosmos. And in this reflection, we find a gentle sense of wonder, awe, and calm, knowing that the galaxy continues its silent dance, its heartbeat echoing through space and time, quietly and persistently, as we return to our place within its vast embrace. Here, in the quiet after the journey, we can breathe, imagine, and reflect. We have traveled light years in thought, through time and space, tracing the arcs of stars, the glow of gas, and the pull of gravity. We have come to the center, gazed into the unseen, and emerged with a deeper understanding of the Milky Way. And in that understanding, there is peace, a cosmic serenity that we carry with us as we look up at the night sky, knowing that every star, every flare, every orbit is part of a vast, intricate, and beautiful whole. Beyond the sun, we drifted past the nearest stars, each one a distant sun with its own story. Some were young and hot, radiating energy in brilliant blue or white light. Others were older, cooler, and more subdued, their motions revealing the structure of our local stellar neighborhood. We observed binary stars dancing together, exchanging material and influencing one another's lives, and we glimpsed the remnants of ancient supernovae, clouds of enriched gas and dust that will someday form new stars. We journeyed along the spiral arms of the Milky Way, where enormous clouds of gas and dust cradle newborn stars. These regions, stellar nurseries, are filled with the quiet hum of creation, where gravity, turbulence, and magnetic fields work together to form new suns. Here, the galaxy reminds us of its continuous cycle of birth, evolution, and renewal. In these gentle, glowing clouds, the future of the Milky Way quietly unfolds. Crossing the central bulge, we found a crowded, ancient environment, dense with stars orbiting in complex paths. We observed how gravity organizes their motions, creating orbits that tell the story of billions of years of galactic evolution. We traced the flow of gas through the bar region and into the central molecular zone, where dense clouds swirl, collide, and slowly give rise to new stars, while magnetic fields guide their motion, shaping the environment in invisible yet powerful ways. As we approached the inner parsecs, the motion of stars accelerated. We saw S-stars tracing tight, elliptical orbits, some coming within mere light days of Sagittarius A*, the Milky Way's supermassive black hole. These stars move with astonishing speed, hundreds or thousands of kilometers per second, obeying the immense gravitational pull of the black hole. We observed how plasma flows, guided by twisted magnetic fields, orbit near the event horizon, occasionally flaring brightly as energy is released in short-lived bursts. At the very heart of the galaxy, we glimpsed the unseen presence of Sagittarius A. Its mass, 4 million times that of our Sun, is concentrated in a volume so small that no light escapes, yet its gravitational influence governs the motion of everything nearby. We saw how matter spirals inward, feeding the black hole, and how some streams are redirected or ejected by magnetic forces. Time itself is subtly altered in this extreme environment, stretching and bending in response to the intense gravity. We have witnessed extremes and contrasts throughout this journey. Stars moving at incredible velocities alongside gas flowing in languid spirals, violent flares of plasma set against the serene, steady orbits of ancient suns. And yet, amid this complexity, there is balance. Gravity, magnetism, and the laws of physics combine to create an environment that is both dynamic and persistent, chaotic and ordered, powerful yet beautiful. Now, as you allow your mind to rest, Let yourself imagine floating gently above the galaxy, drifting away from the black hole, the stars, and the gas clouds, back along the spiral arms, past the bulge, through the quiet stretches of interstellar space, and finally returning to the calm light of our own sun. With each slow breath, feel the immensity of the Milky Way, the steady rhythm of the orbits, the gentle pulse of plasma, and the quiet heartbeat of gravity. Think of the stars you passed, each a sun in its own right, shining steadily in the night. Think of the gas clouds, slowly forming new stars, quietly shaping the future of the galaxy. Think of the black hole, silent yet immense, guiding the motions of billions of objects with invisible hands. Let the rhythm of these cosmic processes lull your mind. Each orbit, each flare, each gentle swirl of plasma moves in time with the universe, reminding you of the patience, the order, and the vastness that surrounds us. As your eyes grow heavy and your body relaxes, let the knowledge of the galaxy's scale fill you with calm. You have traveled light years in thought, seen the Milky Way's spiral arms, the bulge, the central molecular zone, and the heart of the galaxy itself. Every detail, every motion, every flicker of light exists in quiet balance, continuing in perpetuity, while you rest. Let your mind drift with the stars, carried along their steady orbits, past glowing clouds of gas, across vast stretches of interstellar space, toward the comforting center of the galaxy, where time and matter follow their ancient rhythms. Feel the gentle pull of gravity, not as a force, but as a slow, soothing guide, leading you into deep calm. The Milky Way is vast, yet it is ordered. Violent forces exist alongside serene motions. Stars are born, flare, and die. Gas swirls, collapses, and reforms. And at its center, Sagittarius A silently governs the dance of billions of objects, a constant anchor in the cosmic sea. All of this continues while you breathe slowly, comfortably, letting your thoughts float in harmony with the galaxy's pulse. As you settle further into rest, imagine drifting beyond the central black hole, carried gently along invisible currents of gravity and light, outward through the galaxy, past the spiral arms, past the clouds, past the stars, and back toward your own solar system. Every light year you travel is calm, measured, deliberate. The stars slowly recede. The galaxy unfolds beneath you like a vast, dark quilt dotted with glowing threads of light. Now, as the final remnants of consciousness settle and your mind becomes quiet, let the rhythm of the galaxy take you completely. Let the orbits of stars, the gentle swirls of gas, the silent pulse of the black hole, and the immensity of space itself lull you into sleep. Imagine yourself cradled by the universe, weightless, drifting among the stars, carried by the steady, eternal motions of the Milky Way. The galaxy continues to turn, billions of stars in a quiet, majestic waltz. New stars are born, others fade. Gas flows, magnetic fields twist, and gravity guides it all. Time stretches and bends, yet the motions persist, eternal and calm. And as you rest, the universe continues its patient, gentle dance, allowing you to drift deeper into sleep, serenely carried by the quiet heartbeat of the Milky Way. Sleep now, in the calm embrace of the cosmos. The stars, the gas, the black hole, and the vast spaces between all continue their slow, measured dance. You are a quiet observer of this grand system, at peace in the immensity of space, gently cradled by the galaxy's rhythm, and carried softly into rest.